Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. My dear students, today we're going to learn about basically the matter or everything that we can see, we can touch, or we can feel that made up of some particles. Okay, so we know that everything is made up of particle, or in simple word, we can say that the matter is made up of the particles. So let to dive into the chapter and see what are these particles. For example, like here, rock, air, and water. When you see the rock, that is a solid. For solid, we write S. Air is a gas. We write a state symbol for it, G. And water is actually a liquid. For this, we write L. So there are basically three states of matter. So what are these three states in which a matter can exist? There is also a fourth one that we name as plasma. Inshallah, we will learn in the later on. But they have a very big thing in common. They all are made up of tiny pieces, the tiny small pieces for too small to see. For the movement, we will call these pieces as particles. You know very well what we can see the smallest part of any matter as atom. But here it's going to tell you as these small pieces in all of them, either it is solid, liquid or gas, whatever, they all are made up the small or tiny pieces, we name them particles. Particles on the move. Okay, that is very interesting thing to know. All the particles, even in gas, liquid or solid state, they move. How they move? Their movement is different from one another. So what is the type of movement they have? You can imagine that if the particle in a solid state, if they move, then why solid look like as the same? Because if something is moving, it will not in the same shape. It should be D shape. In rock and other solids, the particles are not free to move around, but in liquid and gases, they move freely. Should we understand this thing? As they move, they collide with each other, bounce off in all directions. Only in solid state, they are not free. What it means? Where they are, they should be stay in that position. But the movement is there. We name this movement as vibration. The vibration, you know that when you put your cell phone on vibration mode, it will not move from its position, but it's just vibrate. Understand? So in the same way, in the solid state, particles vibrate. But in gas and liquid, they are free. They don't have the boundaries. Like water is a liquid, it's moving. So particles are moving. In the gas, when you can take oxygen in your nostril into your lungs, carbon dioxide is going out. So the movement is totally free. So the path of one particle in liquid or gas could look like this. Maybe one instant it's here, second it's here, number third second maybe it go there after few seconds, and in this way they are moving from one place to another in a random motion. So what we call this? We call this as a random motion. Till here, any question? You can raise your hand, otherwise type no in the chat.
No, sir.
Okay, easy, super easy.
Yes.
Alhamdulillah. Some evidence for particles. First of all, you should know that if either they are particles or no. So you can see here, when you cook a food, or you can see the light that is coming from a window inside a dark room. Here you can see the particles of gas or dust, or here you can check the smoke that is coming out like the bakur. So the evidence outside the lab is very easy to find out, and also inside the lab you can find out them. So the evidence and to sure about the things are made up of particle, it's 100% accurate. Now come inside the lab, and what you can see inside the lab, that will help you to know. For example, here you can see that place a crystals of potassium magnate. That is, these are the crystals. When these are basically brownish in color, when you dissolve them in water, they are slowly start to dissolving. And everywhere you will see that slowly you will get and find out these particles of crystals, and due to this, the colorless water change its color according to the crystals. Understand? So you can say that in the liquid, how the particles move and how they can change the color. In case of gas, here you can say that you're going to mix two gases, open jar, air outside, done open jar containing few drops of red brown bromine. So this is a gas. So when you let it to go, it will spread everywhere in the jar. So it's mean this ups and down, and this is the second jar. When you let it to move, it will go everywhere. Why this gas will spread everywhere, and why these the particles of crystals are moved in the water? Nobody going to take them and put them here and there. This is a process, or you can say that as a phenomena which we name as diffusion. What we call this? Diffusion. What is diffusion? In very simple wording, I'm going to tell you the movement of particles from higher concentration to the area of lower concentration without any external energy is called diffusion. How? For example, in your room or in your home, anywhere you put the bakhur, okay? So after 5 or 6 minutes, the bakhur will be spread everywhere in the room. This is simple diffusion. Understand? For example, you put here this the bakhur, it's
Yes.
going out. Here its concentration is high. Okay, its amount, the number of smoke is here more. After 5 minutes, it will be go everywhere in the room, and you will feel the smell. Even you are not moving or taking it everywhere in the corner of the room. This is called diffusion. The same thing is going on here, and same thing is going on here. Easy? Okay.
Yes.
So it is a mixing process is called diffusion. So you will see the remaining part and the definition. Now we move toward the next one. So what are these particles? Now come in detail and going to see them, what we call them. These are called atoms. Okay. So these the smallest particle that present in any matter. These are just we discussed, we name them as particles. Actually, it's mentioned here, very small particles that we can't break down further by a chemical means is called atoms. Now, in some substances, the particles are just single atom. For example, argon gas, okay, found in air is made up of single argon atom. If the particle is made up of only one atom, so what we call this one? This is a single atom, okay? In many substances, the particle consists of two or more atoms joined together. Like, for example, we name them as molecule, like water. In water, you have two atoms of hydrogen and one atom of oxygen. Understand? This is the molecular formula of water. So here you can find total three number of atoms joined together. Two hydrogen, one oxygen, total three number of atoms joined in water molecule. Understand, my dear? Bromine,
Yes.
Br2, there are also two atoms like this, hydrogen, H2, chlorine, Cl2. So two atoms, if when they are joined together, they make a molecule. Okay, like nitrogen and oxygen in air made up of molecules. Nitrogen N2, oxygen O2. I also mentioned all here. Number 3. In other substances, the particles consist of atom or group of atom. They carry a change. Okay, sorry, they carry a charge. What it's mean? Somewhere they can get a charge. How an atom or a molecule get a charge? You remember that in the basic concept I explained you. For example, here that is a hydrogen atom. When it lose electron, this hydrogen become H positive ion. Understand? Same here, if Cl atom gain electron from outside, it become Cl negative ion. So these particles are called ions. So these are the examples of ions, maybe positive or negative, like potassium magnet is made up of ion. Easy, my dear? Till here, any question?
No, sir.
Okay. Now, after understanding about the atoms, molecules, and ions, we move next, that is about the seeing particles. So how these particles we can see. So we are now able to see the particles in some solids using very powerful microscopes. For example, the image of the light shows palladium atom sitting on carbon atom. In this image, the atoms appear over 70 million times larger than the really are. So it's just telling you how you can see and how you can see them. Okay, now the basic part of the lesson, let's going to discuss about this. Here, the state of matter. Okay, so here in front of you, there are three states of matter. One is the solid, second the liquid, and the third one are the gases. So what are the difference between them? They tell the difference between a solid, liquid, and gas. It's very easy. So let's see one by one, and also we're going to compare this. Okay, my dear? Not only contrast, but also comparison between them. Now, first, a solid has fixed shape and fixed volume. Look, shape and volume fixed. It will not going to change easily. It does not flow. Even the laptop, the cell phone, the pen, these are the types of the solid material. They will not flow. Think of all the solid things around you, their shape and volume don't change. Understand? Now, second, the orange juice, an example of liquid. Glass filled with water, also the example of liquid, the water inside. Now, what it tells you, flow easily. Look here, it can't flow. Okay, but liquid can flow easily. So it has a fixed volume. Whatever the volume of a liquid you can put in any container, its volume will not change. Volume mean what? If you have 1 liter of milk, even you put this 1 liter of milk in the glass, in the jug, in any pot, it will be 1 liter. Okay, but its shape change. That's the most important thing. Volume fixed, but it can change its shape. For example, a liquid you add in a round bottle, it become a round. If you add a liquid in like this, you can say that as just like something square shape, it will change the shape from round to a square shape container. So the cylinder or where you will pour the liquid, it will get the shape of that container. It take the shape of the container as you pour in it. Now, second is also clear. Number 3, a gas don't have fixed volume and shape. Now, that is very interesting. Lot of gas you can take in your mouth, okay, and then you can blow out. And it's the same way, its shape and volume is not fixed. Even this, a big container, a big cylinder, you can add only like this small amount of gas in it. It can fill this whole the cylinder. And when you can push or force a pressure, you can squeeze it over here. Understand? So what it tells you, it's going to give you the message that the gas don't have fixed shape and fixed volume. It much lighter than the same volume of liquid or a gas. Understand, my dear, what it's mean?
Yes, we understand.
Can you tell me, can you little bit elaborate this thing? It's much lighter than the same volume of solid or liquid. For example, you have a volume of a gas here. this volume of a gas, okay? 1 dm cube. Here, this the dm cube, this the volume of a gas. What it tells you, much lighter than the same volume of a liquid. In the same volume, 1 dm cube of water. Okay, that is an example of liquid, and 1 dm cube you have any solid like iron. So it tells you this is a much lighter. Understand?
Yes.
Okay. Now, so water, solid, liquid, and gas. Let's see their examples. Only one substance, it's mentioned here, like water, H2O, that can show itself in these three states. Water can be solid, like ice. When you put water in the refrigerator, in the freezer, it become ice. Water in the liquid form as a water, okay, and as a gas as water vapors, or steam. You know what is steam? When you boil the water, the vapors
Yes.
coming
Like
out, this
this.
is called steam. There is no change in these three states of water. How? Here in the form of ice, it's H2O. Here also water, H2O. And even in water vapors or in steam, it's still H2O. So it's mean everywhere it's H2O. Understand? There is no change in the chemical composition of this molecule. Only the thing that is changed, that is called physical change or state in change. Understand? From solid, liquid, and gas. My dear, easy?
Yes.
Okay. Amru, what about you, my dear? Please type in chat.
Easy.
Alhamdulillah. That's great. Now, let's see here the other thing. Ice slowly change to water. When you put it out from the refrigerator, it slowly convert into water. When it's put in a warm place, this change is called melting. Understand? When this ice block or a cube, you put it out from the refrigerator or on a warm place, it start to melt. So this is called melting. The thermometer shows 0 degree centigrade until all the ice has melt. So 0 degree is called the melting point. Very important point here. Don't think that if a little bit cube is melted and still there is ice, the temperature will fall down from 0 or rise up from 0. No, it will be at 0. Okay? Because why? Still there is ice. So its melting point is 0 degree. Till all the ice is melted, it will not gain in temperature because that will make the thermometer to stay at 0 degree. Why? Because there is still ice. Understand? Okay. Second, in which you have water. Now, what you're going to do, the liquid water, you start to giving this heat. When the water is heated, its temperature rises and some of it change to water vapor, this one, convert into a gaseous form. We call them as water vapor or steam. This change is called evaporation. Understand what we call this? Evaporation.
Evaporation.
The hotter the water gets, the more quickly it evaporates. As you increase the heat, it will get in so quickly to convert water into water vapors. Understand?
Yes.
Okay. Now, the third one, that is very interesting. Please focus on it. Sooner bubbles appear in the water. Look, these bubbles. As you get here, water is start to evaporate and now bubbles are coming out. What it means? Now it is the boiling point and here water start to boil. B for bubbles, B for boiling. Understand? Understand? Yes. Okay, don't forget this point. The water vapor shows up as steam. Now you can get here a steam that is a visible, okay, but the water vapor here invisible. So you check the temperature of the thermometer, that shows you 100 degree. What this 100 degree mean? 100 degrees Celsius mean that is the boiling point of water. The water vapor shows up as a steam. The thermometer stay at 100 degrees Celsius, while the water boil of 100 degree is the boiling point of water. Now, at this stage, very important point that they can ask you even in the objective, till there is 1 ml of water, the temperature will not increase by 100 degree because water don't let increase the temperature till 100 until it is there, because water has a capacity to gain till 100 degree. After that, it will not let the temperature to increase. What it's going to do, the extra energy or extra heat that is coming in the water will going out in the form of bubble, and you can say that it's convert this heat into steam as water start to leave its surface. This point understand?
Yes.
Okay, now see this one. It is little bit the reverse of what we done here. Okay, what we done here, here it is the reverse. When steam is cooled, now what you're going to do, you take this steam and start to cool down this below 100. This is called the condensation. So during condensing, this steam, mean to say H2O, water in the gaseous form, convert into water as liquid. Okay, now you start cooling this one. Below 0 degree, this water H2O become solidify, or you can say that as freeze, as you know very well, ice here. Okay, again here water. Yes, my dear, is it interesting? You enjoy today's lesson?
Yes.
That's great. Okay, let's move next.
Yes.
Okay. So you can see that condensation or condensing is the opposite of evaporation. Understand? That is your objective points. I am telling you here. So you should keep these things. What is condensation? Conversion of gas into liquid. And what is evaporation? Conversion of liquid into gas. Okay. Number 2, freezing is the opposite of melting. In melting, a solid, for example, ice, melt into liquid. And what is freezing? A liquid is convert into solidified as ice. The freezing point of a water is the same as the melting point of ice. Understand? Okay.
Yes.
Now here, other things can change state to some things also mentioning here. It's not just water, nearly all substance can exist as solid, liquid and gas. Even iron and diamond can melt and boil. Some melting and boiling points are given below. Look how different they are. For example, oxygen, it's melt at minus 219, boiling at 183. So like this, you will see this one. Now showing change of state on a graph. That graph is very, very important. Okay. So make a star. They can ask you from anywhere of this graph, and you know very well about the melting point and the boiling point. Mean to say the freezing of the water from where it going on. So let's see this in detail. I'm just going to tell you and try to explain you only the graph. Okay. Look, my dear, on x-axis, you have a time that will move with minutes. Y-axis, you have temperature. Okay. That is the 0 degree Celsius here. That is minus 25. It means temperature here drops down to 0. Understand? Now, you know that even 0 is too cool. So if you go towards the minus 25, it's also colder one. Look here. Water start to become ice when it reach at 0. Understand? Look, this 0 degree. Anywhere at 0, it ice, or even below than this, it's more, you can say that as a change, nothing happened in it, only it's ice. But this one is your start to warming up. When you ice, it's still here ice, but start to melting. Understand? First thing you understand? Yes, my dear.
Wait, teacher, can you repeat?
Look, below 0, anywhere, it's ice. Okay? When its temperature start to increase, here at 0, it is ice, but start to melt. You can say that at 0 degree Celsius, the ice started to melt. Okay? It will not stay as solid as below 0. Understand? Yes, my dear.
Yes, thank you.
Oh, no problem. Welcome. Now, look here. When it start to move up from 0 to till 100, when it reach at 100 degrees Celsius, it start to boil. Before or below 100 degree, it will not boil. As it reach at 100, it start to boil. Boiling going on, still water vapor getting hotter. So it start to convert into vapors and they become more and more hotter, but there is no change will occur here in the water. Understand? It's just gain in water till 100 degrees Celsius. After that, it will not let to increase in temperature. Yes, everyone. Okay. Now, let's see and discuss this graph in detail. Hope you understand about the points that they mention here in the graph. Graph like this is called the heating curve. That is called the heating curve. Look at the step where the ice is melting. Where the ice is melting? At 0 degree, okay? Once melting start, the temperature stay at 0 degrees Celsius until all the ice has melted. When the water start to boil, the temperature stay 100 degrees Celsius till all the water has turned the steam. So the melting and the boiling point are clear and sharp. What it means? When this temperature will reach, they will do according to the point. Okay, sharp mean as 100 come, it start to boil or convert into vapor. As 0 comes, it start to melt. Okay. So I think till here is enough because we have remaining almost 6 minutes, and in them we can't complete the remaining part of the lesson. Yes, my dear. Is it okay?
No problem, teacher. You can continue this 6 minutes.
Okay, let's see how much we can. When the meeting is finished, then we will finish. The next period, we will start from there, okay? The
Okay.
particle in the solid, liquid, and gases. Let's see them. How the particles are arranged. Water can change from solid to liquid to gas. Its particles don't change. They are the same in the same state, but their arrangement change. As you know that in the gas, liquid, or solid, water is still H2O, because we know that what are the atoms, what going on, what type of change happened in them, only the arrangement of the atoms. So here we're going to see their arrangement. Okay, so what are the types of the arrangement? Let's see here. For example, here you can see in solid, the atoms are arranged properly. You can say that they are stick one another very tightly, or you can say that as the particle in solids are arranged in a fixed pattern, or we call this lattice, in which they will not change their place. Strong forces hold them together. So what we can say that they cannot leave their position. For example, if one atom is here, this one will not go there. Okay, it will stay its own place. So only movement they make are vibration. You remember that? From the beginning of this lesson, I told you in the solid state, they just show only one type of motion that we name as vibration. Or you can say that as to and fro motion, meaning to say that is a pendulum. Okay, so it can come here and it will come here. So this is its to and fro motion, but when you get it actual, it will be steady. It will not look like to move anywhere, or the net movement is zero, as your cell phone when you put it on, you can say that on vibration mode. Now, in the case of liquid, you can see that there is not a fixed pattern in them. So, and they can just, you can say that not tightly packed. They have little bit spaces between them. In solids, there is no space between any type of atom. So you can find easily they are tightly packed, but here not like this. The particle in a liquid can move about and slide past each other. Look, when you put your hand on other hand, it will easily, you can say that move or slide from one another. In the same way, the particles or the molecules here in solid liquid state, they slide past each other. They are still close together, but not in lattice. Look, there is a little spaces, close, but not like solids. The force that hold them together are weaker than a solid. There is also a force present in them, but this force is weaker than solids. Understand? Now the third one here that we're going to see about the gas. Easily you can see the particle in a gas are far apart. Look, one molecule is here, second is here, third is here. They are far away from each other and they move about very quickly, and their speed is too much. They move randomly, okay, very quickly. There are almost no force holding them together. First of all, look, they have a huge distance part away from each other. That's the reason they are not attracted to each other. Yani this will not come closer to this one and this will not come. And there is no force. That's the reason. They collide with each other and bounce off in all directions. So for example, this molecule is go there and here is a wall. It will collide it and bounce back. Or even they can collide to each other, then they will move apart from each other. So this a simple, the comparison you can see here, and the state of these three solid, liquid, and gas, how molecules behave in these states. Okay, so next is the
Teacher,
yes,
this will have been same in the pressure cooking machine, yes?
pressure cooker is another thing. In a pressure cooker where you exert pressure, okay, you collect the gas that put extra pressure on the meat or what the thing you want to cook. So what happened, even there is no pressure cooker and you just open the lid of the pot, all the gas go out. It will not put extra pressure on the food. So the extra pressure just force on it and it will make it to cook quickly and cook better. Okay, understand?
Yes.
Okay. So here melting, when a solid is heated, its particles get more energy and vibrate. For example, you have here a solid. You start to give heat. What happened? This heat actually gives energy. Then the molecules, they are first just vibrate. They start to move more quickly because they get energy. in the form of heat. Okay, and then due to this, they start to vibrate just like liquid. Understand? And this solid convert into liquid. Understand, my dear? So this make the solid expand. At the melting point, the particle vibrate such a way that they break each other their position and the solid turn into liquid. Now after that, you still giving the heat and they will not remain on their position and they will convert into liquid. Yes, my dear. Till here, any question?
No.
No.
So still we going on to giving them the heat, and then this heat will still going on in the liquid, and then the liquids also going to disrupt it in their position, and then our point will come, they start to boil. When this overcome the force of the liquid, they just join them all together, then it start to boil.